Let's go over the transformations practice test. So in this video, we will try to hit every problem on the practice test, go over the basics. And if you feel like there's something that you're like, wait, I need to see that again, then you go watch the video specifically for that. I'll try to do the easier ones quicker so that you guys can fast forward through this part. If you don't need the basics again, just fast forward and skip to the harder problems. So watch the part that you need to get. So for this one, we want to understand the idea of a translation, right? So we should know that this is taking us 5 units in a direction, and we should know that the other thing is moving us 2 units in a direction, right? Which direction is it? Well, don't forget that with translation, right, the number that we see in there with x is going to tell us whether or not we go left and right. If it's positive, we go right. If it's negative, we go left. Well, it's positive. This means we're going right. Okay, now, the number that we see inside the parentheses with y, okay, this number is going to control whether or not we go up or down. So we go up when it's positive, and we go down when it's negative, and that's pretty, pretty memorable, right? I think you guys know that up means plus and down means minus, right? So we want to go 2 units down, again, because that's a negative. Okay, so we just follow this procedure, and we move all the points according to that rule, right? To W, I go 5 units right, so I go 1, 2, 3, 4, 5, and then I go down 2, and then I call the point W prime. Okay, we follow the same procedure to the other ones, right? So for X, I'll be taking 1, 2, 3, 4, 5 steps, and then I go down 1, 2, and so I'll be right there, and I'll call that X prime, okay? I'm going to erase all the little marks. I think you guys know that I'm erasing them so you guys don't get them in the way of the picture. But I want you to see what I'm counting. Okay, so for U, I'm going to go 1, 2, 3, 4, 5, and then down 1, 2, and then I call that point U prime. Okay, so we follow that same procedure, and like I said, you don't have to put these little marks that I'm putting there. I'm just showing them so you guys can see exactly what I'm counting. So for V, if I go 1, 2, 3, 4, 5, and then I go down 1, 2, I call that point right there V prime. Okay, so again, like I said, we clean up those other marks, but leave the points of the image of our transformation. Okay, so don't forget, that's what we're doing. The image of a transformation, okay, is what you get after you move the shape, right? So don't forget, the pre-image is before. That's this one. Okay, and the image is after we move it. All right? So this problem would be complete. We move on to the next one about reflections, okay? And that brings me to this little list of arrow notation that you guys might want to write down, okay? So when we look at the reflection across the x-axis, we should be able to see that a reflection across the x-axis, okay, is going to take a point from the top and bring it to the bottom. So if I had A and reflect across the x-axis, A prime will be down here, right? Which means that all that changed was the y value, right? Or if I have a point on the bottom, then the reflection would have to go to the top. So in that case, the y value would change to opposite signs. So let's say that this was like the point 2, 3. Then this point down here would be 2, negative 3, if it's the reflection, right? And if this point was negative 2, negative 3, right? Then this point up here would be negative 2, positive 3. Again, because the y coordinates have to have opposite sign when we reflect across the x-axis, okay? We can also see that they have the same exact x value, right? Because it's not going left and right, that value can't change, right? But again, the y value has exactly the same number, but just the opposite sign, right? So when we reflect across the y-axis, and something similar happens, but it's just the other direction, right? So if I get rid of this, we'll take a look at that example too, and realize that when I reflect across the y-axis, my point is going to be moving left to right. Okay, so reflecting across the y-axis means that I have a point over here, and let's say that that's like 3 steps or something. Well, I'd have to take another 3, right? But that's negative 3, right? So what happens to my point? Right? If that's 2, we see, hey, well, the y coordinate didn't change, right? But in this case, the x coordinate changed to the negative version, right? And so this is why we have this when we reflect across the y-axis, the x coordinate changes. But when we reflect across the x-axis, the y coordinate changes. All right? So I guess one way that you could remember is that if we reflect across an axis, then that number cannot change, right? So we're reflecting across the x-axis. Well, the x number can't change then, okay? This only works for the axis, and if we got to reflect across x equals like 1 or something, it works totally different. Because don't forget, again, the x-axis goes left and right, but x equals 1 is a line that goes up and down, okay? So we'll keep that in mind. Let's go through these reflections. Okay, so reflect across the x-axis just means that we move them across this. So I told everybody, highlight the x-axis and go darken it. And then we see that I prime is going to be right on top of I, because when a point is right on top of the mirror, it doesn't move. Okay? Now J is 1 away, so I got to go another 1 away from the mirror and call that J prime. H is 5 steps away from the mirror, so I got to go up another 5 steps from the axis of symmetry and call that H prime. So now if we just connect our dots, we have the reflection of that triangle, and we're complete. So let's go try number 3. Okay, now when we look at number 3, we should see again the y-axis. That's this one. So always go darken it so that way you don't make any little mistakes. And now let's say that I want to reflect K. Well, I can see that's 2 steps, so I got to take another 2 and then call that point K prime. I is only 1 step away from the mirror, so I got to take 1 step to the other side, and I can call that I prime. J is 3 steps away, so I got to take another 3 and then call that J prime. Okay, and if I connect those points, I have my triangle that got reflected across the y-axis. So I hope you guys can see again all that change, right? This point K is 2, 0, and this one over here is -2, 0. Okay, so that's what shows us that when we reflect across the y-axis, right, the thing that changes is my x value, right? The y coordinate can't change again, right? When we reflect across the y, then y can't change. All right, so now we'll go take a look at some rotations. Or actually, I think we have a couple reflections left, so we'll do these ones, all right? So now that we get to our horizontal and vertical lines, let's be careful because this is what I was just talking about. Step 1 would be underline what it tells you to find, the reflection across y equals 1. Then we want to go to the y-axis, okay, and on the y-axis, I want to find the line that's 1, okay, and that's this little hash mark right there, right? So we take the tick mark and make it a lot longer, okay, and this is the line, y equals 1, okay, that horizontal line is y equals 1, right? So we want to reflect across that, okay, so what that means is that I count, again, my steps, right? I can see that R is 2 steps away, so I got to count another 2 steps away and put R prime right there. Okay, T is 2 steps away. So again, the reflections from the top go to the bottom, but the reflections from the bottom have to go toward the top. Okay, S is 3 steps away. So that means S prime would be 3 steps away on the other side of the mirror. So that's S prime. So now if I just connect these points, I'll do it in red maybe. Okay, we should have that triangle. All right. So this is how you do those reflections across the x equals or the y equals. Let's go try the next one for x equals. So in this case, we have x equals -1. All right, the most common mistake is that somebody puts the line right here, okay? But that's not true, okay? This is not the line x equals -1. All right, to do this, what I have to do is go to x and then find the number -1. Well, -1 is on this side. So again, you take that little hash mark and you just make it really long. Okay, this is the line, x equals -1. Every point on that line has x equal to -1. So I want to reflect the points from the right side to the left side, and from the left side, they got to go to the right. So L is 1 away, so I go another 1 point away and call that L prime. M is also 1 away, so I go another 1 away and call that M prime. But K is on the left, so I got to count 3 steps this way and go another 3, and then call that K prime. So now if I just connect my points, okay, I've connected the triangles that I needed. Just don't forget that all these other little lines were extra just for me showing you how to count, so I hope that doesn't distract you too much. All right, so again, all we really cared about was the triangles, right? So there we go, guys. This is the way that you should have these reflected on number 5. So the rotation 180 degrees about the origin, that brings me to this slide where you guys should have all of your rotations. So rotations are right here. Okay, so when we rotate 180, it means that we just change the sign of both points, right? So we could do a couple examples right here on this thing. Maybe you guys will get my point. All right, let's start off with a point. Let's call it A. Let's call it 3, -2. Okay, and so then I'll show you how to do an A prime if it was this one, an A prime if it was this one, and A prime if it was that one. And then maybe you guys can see the way the pattern works, all right? So for 180, all we do is just change the sign. So the +3 becomes a negative, the -2 becomes a +2. Okay, for 90 degrees clockwise though, what this says is I gotta change the two numbers. So I gotta change the 3 and the -2. So -2 goes here, and the 3 goes there. I switch them, right? Notice the X and Y switch spots, okay? But the one that I have to change the sign of is the one that I see on the right. So I have to change the sign of this one. So the +3 needs to turn into the opposite sign, into a negative. All right? Again, now going counterclockwise, look, it does the same thing. It switched the Y and the X. So the -2 goes here, and the 3 goes here. But now, it tells me you got to change the sign of the one on the left. So I'm going to change the -2 into a +2. And now this would be complete. Okay, so this is the way that these rotations would all look. Right, so understand how to do this. Again, when we see the -X or -Y, this means that we have to change to the opposite sign. So we could do these hopefully pretty quickly, but you got to watch out for messing up the signs of values, okay? So I guess I'll do this one with you numerically. Okay, so S is 3, -3. T is 1, -1, and U is -4. Sorry, I did that again. It's a -2 and -4. Okay, so we want to change the sign of all of these points, right? So S prime will turn into -3, +3. T prime is going to turn into -1, +1. Okay, and then U prime is going to turn into +2, +4. Okay, it would have been good if I wrote this transformation ahead of time, because then you could always kind of refer back to it, make sure that you're following what you said you were going to do. So now if we put these points into the space where they go, we should have our shape correct, right? So S prime would go right here. T prime, -1, that makes sense, right? And then U prime would be 2, 4, so 2, 4, right there for U prime. So if we connect those points, we have our shape that got rotated 180, okay? There was another way to do the rotations where I showed you guys how to mechanically kind of rotate your paper and count. So if you're interested in learning that, send me an email or stop by, maybe even ask a partner if they could show you the way to do it by flipping the paper around. Might be one way that you could describe it to one of your classmates and they could show you how to do it by counting, all right? So now we'll go to number 90. We're going to have, obviously, I think you guys can see that I'm going to cover everything, right? So if I do clockwise, you know I'm going to do counterclockwise too. So you got to be able to tell the difference between them. All right, so let's try to notice, right? When we do clockwise, okay, we know that clockwise means, right? I usually ask people which way is clockwise, and they tell me from the top to the bottom, okay? But that doesn't really make sense, because no matter which way I go, it's going to be from the top to the bottom, right? There's nowhere else to go if you're at the top, yeah? So, you know, clockwise is from the top to the right, yeah? Counterclockwise is the other way. So I want you to notice how when we do clockwise, you know what, we have to go from the top, right, to the right. Well, notice I actually end up changing the coordinate on the right. And then counterclockwise is where we go from the top to the left, right? And notice we end up changing the coordinate on the left. So a lot of my students seem to already have kind of internalized that, but I'm going to say that one more time to make sure you guys can think about that when we're doing this problem. Okay, so clockwise, right? Let's say I forgot everything and I want to make sure that I get this right. Well, let's think again. Clockwise, right? That's from the top to the right. So I know I have to switch the Y and the X, but then the top to the right, which one do I change? Oh yeah, the one on the right. Okay, so that's all we got to do. So we do L, K, M, and put our points there. We see L is -1, 0. K is 3, -4. And then M is 1 and -5. So I'm rushing a little bit so that this video doesn't go over, so you guys have the patience to even click on it. But you guys should be more patient than me, okay? Make sure that you count it, right? Sometimes when I'm putting these numbers down, notice that I might miscount, so just double check your work, all right? So notice it says to switch the numbers, right? So I switch the 0 and the -1, and I change the 1 on the right. I switch the -4 and the 3, and I change the 1 on the right. I switch the -5 and the 1, and I change the 1 on the right. So those are my points, okay? So 0 and up 1, this would be L prime. Left 4, down 3 would be K prime. And then left 5, down 1 would be M prime. And if I connect these points, I should have my shape that got rotated 90 degrees clockwise, okay? Always double check that. I have a lot of people on homeworks that are turning in reflections. All right, so I took some points off. If you did a reflection and it said to do rotate clockwise, your grade might not have been a full score. So double check all those things, okay? Make sure that you think about it too, right? Clockwise means that I go from the top to the right, around that way, right? So is that what happened? Did this point get rotated to the right? Okay, it did. Always think about that. It's really easy to go the opposite direction, so double check, right? Because that part's your job, to double check and make sure that you're right. Okay, counterclockwise. We'll do this one. And in this case, we'll start off with our numbers. All right, so let's do okay, V is left 5 and up 3. U is left 4 and down 2. W is left 2 and down 1. All right. Okay, and then our arrow notation would be a good thing to write ahead of time. Probably should have been the first thing I wrote. So now think about it, right? Which one do I change? Well, it says counterclockwise. And counterclockwise is where I go from the top to the left, change the 1 on the left. All right? So this tells me I take those two numbers, 3 and -5, and I switch them. All right? But after I switch them, I change the 1 on the left. Take these two, switch them around, and then I change the 1 on the left. I take these two numbers and switch them around, and I change this one on the left. And so here we go. This is the thing we're working with, right? So I go left 3, down 5. And I get that point right there is V prime. And then this one, U prime, is right 2, down 4. And so that's U prime. W prime is right 1, down 2. And so that's W prime. And there we go. It went counterclockwise, and we can double check, right, that we can see, hey, look, you know, and another way to think about this is it says about the origin. So think about it. If you ever connect your points with the origin, it should look like it made a right angle, okay? And we can see that it went counterclockwise. It's going the opposite direction from the clock, right? Again, don't ever forget, right, the pre-image is this one. That's what we started with, right? And the image is the one that gets all the primes and everything, because after we move it. So if you can do up to there, that's the basics. All right? You might be all right. You might be able to get like a C on this thing if you can do those ones. But we've done a lot of activities lately that that go a little farther. So there's one new thing that I put on the test because I felt like we're moving in this direction anyway. We're going to be needing to learn how to graph this line, so I might as well teach it to you now. Okay, so in this case, the arrow notation is much simpler than all the other ones, I think. Okay, to reflect a point across the line y equals x, all we have to do is just change the order of the two coordinates, and that's it. Okay, so the one thing I do want to talk about is how do we graph this line y equals x, okay? Well, you might remember I taught you guys how to do a y equals mx plus b, how to graph that, and we knew that the m was the slope, and we broke that down into rise over run, yeah? Okay? And then we saw that the B was what's called the y-intercept. And so that was a point where our line that we're graphing would cross the y-axis, right? So let's look at what we have here, okay? Because we have a line that says y equals x, okay? So first of all, I don't see anything here for B, and I don't see anything here for M. So what are those values, okay? Well, M is not a 0. M is an invisible 1. Okay, don't forget that we usually don't write 1 times x, all right? So there's a 1 there, okay? But b, there's no value there. We're not adding anything. And so in this case, it means that b is 0. Okay, so that's the way this works. But don't forget that our m is our slope, and that's our rise over run. So if our rise is 1, then what's our run? Well, 1 is equal to 1 over 1. So in this case, when you see a number that's just a 1 like that, that means that we're going to go over 1, up 1. Okay, but again, our y-intercept is this number right here, 0. So what this tells me is I got to start in the origin. I go to 0, 0. On the y-axis, I go to 0, and I put a dot. And then I use my rise over run to draw the line. So I go over 1 as my run is to the right, and then I go up 1. Okay? So from this point, I'm going to go over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. Okay? And so we see that we have this line. Okay? This is the line y equals x. Why is this the line y equals x? Well, let's look at every single point that we've drawn on here. Okay? Every point on this line that I'm drawing has the y coordinate equal to the x coordinate. Okay, notice that they're all the same. 4, 4, 5, 5, 6, 6, so on and so on. Right? This would be -3, -3, right? They all have the same x and y coordinates. So that's why this is the line y equals x. We want to show all the points where y equals x. Okay, so now I'm going to darken that so we can see this is the line. This is our axis of symmetry. This is the first time we got a diagonal line. So I'm a little nervous about this because I know we have not done so much focus on this, okay? But the good news about it is that the arrow notation is as simple as we could possibly get. All we have to do is change the order of the two numbers, and then that does what we need to do here, okay? So I'm going to erase all these other points that were kind of me just teaching you guys what's happening. And let's solve this problem numerically instead of looking too much at the picture. All right, so we'll do L, K, and J. All right, so L, K, J. What are the coordinates? L is 3, -2. K is 4, -2. And J is 4, -4. Okay, so when I do my primes, right, we follow our arrow notation, this thing right here. This says all I do is change the order of my x and y. We don't have to change the sign at all. We just switch the order. So instead of having 3, -2, I have -2, 3. Instead of having 4, -2, I have -2, 4. And instead of having -4, -4, we have -4 and 4. So if I put those points here, we should have exactly what we need. So I go left 2, up 3. Call that L prime. K prime will be left 2, up 4. So I call that K prime. And then J prime says to go left 4 and up 4. So that right there is my J prime. Okay, now we can see, if I connect those in red, hopefully, that we have the point that we need. Okay? So every now and then you might have to move your label out of the way so you can see your picture a little better, but this is good enough. Okay, I hope you guys can see that our points got reflected across the line y equals x. Not the y-axis, not the x-axis, but the line y equals x. All right, this little line that goes over 1, up 1 every time. All right, again, this arrow notation is easy, so you'll probably have a couple ones on the test, so just switch around the x and y's and you'll be okay. I think this would be a great time to check understanding because I've been doing so many problems. So why don't you try this one on your own right now? See what you think the answer is. Write your STU, write the coordinates, write the arrow notation, and figure out what you got to do. Okay, pause the video because I'm going to click the answer in 3, 2, 1. All right, the answer is like this, right? So as we see, if we draw a line going straight this way, our y equals x, we will have our points got rotated exactly like this, right? So let's take a look at what it looks like. Okay, like I said, this is the line y equals x. It's going over 1, up 1 every time. All right, so what happened, right? Well, this point, that was the point -1, 0, what did it turn into? It turned into 0, -1, right? This point over here was the point -2, 4, all right? But it turned into this one, which is at 4, right? So this is the point 4, -2, because it's down 2. You see? They just switch, all right? S over here is -3, 0, okay? But this one is 0, -3, all right? So that's all that happened, okay? So make sure that you follow the arrow notation and you read and that you don't, think that this is a vertical line. It's a diagonal line. Okay, so this brings us to the multiple choice questions. All right, and these are, some good ones, because in this case, I get to make sure that you guys know what a pre-image is. Again, the pre-image is before I move it, and the image is after I move it. So you have to know the difference, okay? And in this case, I chose one that was the reflection across y equals x, just so that we could see it, all right? So notice that the point K didn't move, and that's because it's right on the line y equals x, right? So this one's pretty obvious. We should be able to eliminate these other ones. Maybe let's talk about why I can eliminate those, so we get a little more literacy here. All right, this one says that the point should be going right 2 and up 6, right? But I can see that L did not go up 6, so it can't be that, all right? This one says that all the points moved up 1, right? This says y plus 1. But look, L didn't go up 1 because L's all the way over here, so it can't be that either, okay? So now I got only one thing to make up. Is it a 180 degree about the origin? Well, let's look at it. What happens when I connect L with L prime? Does that go through the origin? No. Okay, so this is definitely not a 180 rotation about the origin. A 180 rotation about the origin would go through this point. And so since that's 2 away, I have to go another 2 away. And L prime would be here if it was a 180 about the origin. All right, so it can't be that one either. This is a reflection across y equals x. And again, if you looked at all the numbers, you would see that it's just the same as what we did last time, right? This point right here is 0, -2. But this one over here is -2, 0. Right? This point is -2, -4, but this point is -4, -2, right? The K is the one that didn't change, right? And so what's that all about? Well, what is it? Because it's -3, -3. So even if they switch places, they'll still be in the same spot, see? So the answer has to be A, all right? Reflection across y equals x. All right, you better do a little bit of thinking on 12 on your own. It looks like I accidentally highlighted the answer, so I better undo that. Again, the beginning is when it doesn't have the prime, and the after is when it has the prime. So you should be able to see, did this thing move up or down? Check your understanding right now. The shape moved down, okay, because the pre-image is before, and the image is after. That's why this is H prime. So notice H went down 3 units, right? So it has to be B. This is the only one that says anything about anything going down 3 units, okay? And you can see this is not a 180 rotation because it's not, right? A 180 rotation would send F to over here, right? So it's just not true. All right, so the answer here is B. The translation, 1 unit left and 3 units down, okay? If you just counted, you say, oh, look, let's see how we get to H. You go 1 left and down 3. And you can just look through here to see which one says to go 1 left and down 3, all right? All right, we're done with that first page, and now we get to the last page of the test. So these ones were really important, and I gave you guys an arrow notation to make our life a little simpler when we got to these problems. So here they are. All right, these are our double reflection arrow notations. All right, I really like to use these to make sure that you guys actually learn something, and you learn how to do experiments and see things move around in the plane. So the double reflections are all right here, okay? But you guys got to notice the difference, right? In this one, we go first across A, and then we end up going across B, right? See that? What happens on this one? This one says first we go across B. And then we go across A. So that's different. Notice the order is what is different. So what I want you guys to see is the only thing different between these two is the plus and the minus. All right? That's the only thing that's different. So notice, since A is bigger than B, this is the thing that we're going to stick with, okay? If A is bigger than B, then that means if I first go across the smaller one and then across the bigger one, I go to the right, okay? This one pushes me to the right. But if I go first across the smaller one, right? So if I go first across the bigger one, because B is bigger than A, and then I go across the smaller one, this is going to push me to the left. It's not going to push me to the right. It's going to go the other way. Okay, so I have to pay attention to those, all right? Likewise, notice the same thing happens when we have Y. Okay, the difference is that when we got y equals a and y equals b, okay, this means that my point is going up and down. Okay, so just like last time, I end up adding in the case that I go first across a and second across b, right? Because again, I'm doing the little one first and then the bigger one. Okay, so that ends up pushing me up. You got me? That pushes us up. But this way, if I go first across the b, right? If I go first across the smaller one and second across the bigger one, sorry, if I go first across the bigger one and second across the smaller one, then I'm going to go down instead of going up, and that's why this value is a minus right there. Okay, so eventually this will make more sense, but we had to practice a few more. So let's get these ones on here. All right, this first one. We have a reflection across 50 and then across 80. So notice this is my A and that's my B. Okay, we're going first across A and then across B. You got that? So what does that mean? Which arrow notation should I be using, right? First A across B, I should be using this one, right? I should be using this one up here, the one that says I go to the right. You see that? This one's going to push me to the right. We said this one will push me to the left, right? This one will go up, and this one takes us down. Okay, that's the way these double reflections work. So let's make this happen. We're going to go right, and we're going to use that equation that I was just talking about. So here we go. Again, like we said, this is A, and that's B. Our arrow notation is right here, okay? I gotta be real. In class, we did this problem really, really quick, and you guys kind of got the idea. So, I mean, let's do it the fast way first, okay? You guys should realize that if I have x equals 50, and if I have x equals 80, okay? When we did our experiments in class, we saw that the only thing that mattered was the distance between the mirrors, okay? In this case, right, my b is 80, and my a is 50. So b minus a is 80 minus 50. What's 80 minus 50? It's 30, okay? That's where the 30 came from, right? And so what this is telling me is that to reflect across these two mirrors, I have to take my xy point, right? And I have to do x plus 2 times 30, right? Because b minus a, 80 minus 50, and that's 30. Okay, but what's 2 times 30? That's just 60, right? So this tells me, okay, I got to do x plus 60, right? I double the length of the mirror, but you guys can do that in your head, right? What is 2 plus 60? It's 62, okay? The y coordinate can't change again. Notice that the y coordinate is the same when we do a double reflection across these vertical lines. All right, so all we have here is 62 and 3. Again, remember that all that matters is the distance between the mirrors. All right, so let's try another one. 14. Okay, is this one going in the correct order? Are we going first across A and then across B? That's what you want to try to identify. All right, so it looks like we're going first across A and then across B. We're going in this order, right? We did the littler one first. So now what happens? Well, how far apart are those? What's B minus A? Well, 180 minus 140 is 40, right? These mirrors are 40 apart, okay? But 2 times 40 is 80, and that's what we have to move. So what do I add this 80 to, right? The 80 is going to get added to the x coordinate, right? So 80 plus 4 makes 84. Again, we're using this number as the point that we're moving, okay? And the y coordinate doesn't change. So I hope you guys see, we don't really need to draw a picture once you guys understand how to do these problems. Let's take a look at 15, so that we touch all of these ones. So 15 tells us again to start with the smaller one. So this is our A, and that's our B, okay? So how far apart are those? They're 50, right? B minus A is equal to 50. But 50 times 2, right? 2 times 50 is 100. What do I have to add 100 to? Well, remember, we're adding this to the x-coordinate of our point. And my x-coordinate here is 10, right? So that means I have 110, and that the y-coordinate does not change, okay? Now, all of these problems work the same exact way, Because we always did the smaller number first, and then we did the bigger number. Okay? In this next example, we're going to take those training wheels off finally. All right? You guys have to take it in a different situation. So what's going on now? Okay? We have y equals a. You guys see that, I hope. Okay? It says y equals a, and we're reflecting across y. So it looks like it's going first across 120 and then across 100. So wait, let's think about that. What's going on? We know that A is bigger than B. Okay, so what's B? Well, the B must be 120 and the A must be 100, right? So, what does that mean when we get B minus A now? What do I get? We're going to get 120 minus 100. Okay? So the point that I'm trying to make is, are we going to go up and down? Are we going to go up or down? Okay, this gives me a this gives me positive 20, right? So think about it. Are we going up or down in this situation? Well, look, we did the bigger number first, and then we did the smaller number. And every other time we've always been going from smallest to biggest when we reflect. So this means we're not going to go up. This won't push us up. This is going to push us the opposite direction. This is the one that pushes us down. Okay? So how many times do I got to go down? Remember, we saw we have to go down double the distance between our two mirrors, between our axes of symmetry. So what's 2 times 20? 2 times 20 is 40. Okay? But since I'm going down, what changes, right? The x-coordinate can't change. We're going down. Okay, so that means I have to have here 7 minus 40. Okay, and what's 7 minus 40? Okay. You get your negative 33. And that's the answer. Okay? So again, think about that. This might be slightly confusing, but I think you guys can figure it out. Again, all that matters is what order we go in, right? So if we take a look at this little slide, it explained everything, right? If we go first across A and then across B, we're going right. If I go first across A and then across B and we're going across horizontal lines with Y, that means I'm going up. Okay? So notice the two ones that are positive, the up and the right, are the ones where we go in order, right? Where we start with the smallest one and then do the bigger one. All right? The ones that go left and down are the ones that kind of go backwards, right? Where we start with the bigger number and then we reflect across the little number. All right? So we got other ground to cover, so we'll move on. Double reflections was like a whole couple days in class. Now we'll get to this thing. All right, this was also a very big day. I knew that this would be a test question this year, so I tried to make sure that we really hit the nail on the head in our lesson. So let's talk about the way this works. The first point is A. So I should have labeled that, and point B should be right here. And we should label this thing as the river. All right? Now, on the example I give you, I actually don't want to give you this line. I'm not going to draw it for you. Like, I'll give you something, and then you'll have to graph the line to make the river. Okay? So in this case, for the practice problem, I drew the river for you. So just understand that's not going to be the way it is on the test day. Okay, the key that I told everybody to solve this problem. We spent a lot of time doing this, and I let you guys try to discover it on your own. But the most important thing was for you guys to understand really how to use a ruler and, kind of understand the process of this problem, right? We were trying to find the shortest distance to go from A and then to the river to get the water, and then we wanted to go put the fire out that was in the tent, right? So what we do in this problem, right, is we have to reflect the tent, all right? So I'm going to count how many steps away the tent is. It's 5 from the river, so I count another 5 steps, and I call that point B prime, all right? That's me reflecting the tent. Now, the trick to this problem was that we wanted to connect a straight line from A to B prime, all right? So the first step that I would say would then be after we reflect the tent, we're going to connect A to B prime. Okay, after you connect A to B prime, I want you guys to notice that that intersected the river at a specific location, okay? That place is going to be what we label as point C, Okay, this should feel very familiar to you guys. You guys were here this day, right? So after that, we have to draw, we're going to connect B to C. All right, so now I'll just connect that. And again, we do all of this with a ruler. Okay, so do all of that with the ruler. And then we want to measure everything. Okay, we want to measure the length of AC in centimeters. Okay, so we measure AC. And then 5 is we measure BC. Okay, and after that, you're going to write it out, okay? So I think you guys should know what to do. You're going to write AC plus BC equals, and then you should have your little values, right? You should have your centimeters for this one, your centimeters for that one, right? And then we should have a total of all the centimeters, okay? And that would be this problem being complete, okay? So that's the procedure. If you were here in class that day, it should totally ring a bell. It should make sense to you. You should be able to do it. I'm not going to be able to hold the ruler for you and start measuring and drawing lines. So if you get, this problem, you get stuck on it, that's what happens. Okay, so everything's right here in the video. I think I covered everything except the word problem. So I know the video is getting a little long, but at least everything's in it. Let's go think about this one. All right. If you reflect a point across the x-axis and then reflect it across the y-axis, then it'll be the same image as a rotation 180 degrees about the origin. So why should this make a lot of sense? Okay, let's think about this. Well, so in this example, we can see that a rotation 180, right, follows this procedure up here, right, where we change the x and y, they both become negative. So let's try to analyze what the sentence says. It says that if we reflect first across the x and then across y, that it'll be the same thing as a rotation 180 about the origin, okay? So we can see that at the end of a rotation 180, right, we get the negative x, negative y. So let's just go break down what happens if I reflect across the x-axis. Well, when I reflect across the x-axis, we saw earlier that it's the y-coordinate that changes, right? But now, notice that I have to do the next one, right? So it says after we reflect across the x-axis, we got to do another one. So that's what we're going to do, this reflection across the y-axis, okay? But when you reflect the point across the y-axis, the only one that changes is the x. And so now we can see that we ended up with the same exact thing. I hope you guys can notice that this one ended up with the same thing that this one ended up with. Okay, so the answer here is that this statement is true. Okay? None of those other points would be a counterexample. All these other ones would all be an example of this. If you reflect any of those points across the y-axis and in the x-axis, it'll have the same as if we rotated 180, right? Think about it. If we do this 180, then the negative 2 and negative 3 turns into positive 2, positive 3, right? But what if I take b and then turn it to b prime, right? What if we flip that across the x-axis? Well, like we said, that changes the negative 3 into a positive 3. And then if I do b prime prime, right, I have to flip that across the y-axis. And so that means that the negative 2 is going to turn to a positive 2. So look, either way, I got the same value. Okay, so that's why this is not a counterexample. All right, these are all examples. And that's kind of important, that if a statement is true, that you realize there is no counterexample, okay? If something's true, that means you can never prove it wrong. All right, so now we got another word problem for you guys to think about. Number 19 here. Okay, if you rotate a point 90 degrees clockwise about the origin, and then reflect it across the y-axis, and then reflect it across the x-axis, its image and pre-image will be the same, okay? This would be a good experiment for you guys to do. I would feel like you guys are doing critical thinking. And why do I know that about half of you guys are going to try to just guess on this thing and move onto something else? You have to be patient about your reading skills, man. You can't expect the things to just jump into your brain. So practice reading and look at the words and think about them. All right, that's the only way to go, really. So this tells me to take a point and rotate it 90 degrees clockwise, okay? But let's just see what that would mean. So what if I start with x, y, and rotate it 90 degrees clockwise? All right, we'll do a little shorthand here. 90 clock, we'll say. Okay, well, that's where we get the yx, okay? And again, clockwise is top to the right, so I changed the one on the right, yeah? Okay, then it says to reflect it across which one? The y-axis, all right? So we'll write reflect across y-axis. Well, reflecting across the y-axis, we just saw a second ago that means this value is going to change to negative, right? So right now we got negative y, negative x. Okay, and then we could see what happens if I do the last part that it says, and then reflect it across the x-axis. So if I do this across the x-axis, then what happens? Well, we saw earlier, we reflect across the x-axis, the y-coordinate changes to the opposite sign. So that means the negative x will become a positive x. And so this is what we got. Okay, look, it started off as this, right? And then it turned into this, right? Okay? And so it says that, it says its image and its pre-image will be the same. Is that true? Okay? So you guys could think about this for a second. Try to analyze all of these. Okay? Don't forget, we're looking for a counterexample, and if something's true, then we can see that it's obviously true. We could also try to experiment doing some actual rotation. So what if I put a point here and call that A? Right? If I rotate that 90 degrees clockwise, then A prime is here. And if I reflect that across the y-axis, then A prime prime would be here. And then now we have to reflect that across the x-axis again. So A triple prime would be right on top of itself. Okay? Is this point, right, is this point here? No, right? That is not the same. So in this case, any of these points would be something that you could use as a counterexample, right? This idea is not going to be true. So you should be able to take it and run with it, all right? Now, like I said, on this one, it's not true, so do not select true. On this one, you can pick okay, I must have had a mistake on there, so you guys could neglect that answer that it said true. This is definitely not true right now. I probably had to take away one of these words off, all right? So at any rate, any of these points would be true, okay? We can double check why, any one of these points would be a counterexample, and the reason why they'd be a counterexample is that they show that this does not work, right? If I take one of these points and do this procedure to them, I'll have something else, right? Like we said earlier, B prime, I take my 3 and my negative 2, that's the clockwise. If I reflect this across the y-axis, then B prime prime means I got negative 3, negative 2, okay? And then B triple prime, I have to reflect that across the x-axis, so that means that the y-coordinate is going to change, okay? And so we'd have positive 2. So notice that this is not this, right? The pre-image was this one, and the image is this one when we get all the way at the end, after I do all of these movements, right? And so this would be a counterexample, but so would this one, and so would this one, okay? This statement is not true. That's how we have it here, all right? So sorry about the answer key. I think I changed this question after I made it. Okay, now for number 20 here, we did this problem in class, but we should be able to see that this is a ridiculous statement, right? It just can't possibly be true for several reasons. Okay, one is that when you reflect the point, it doesn't always have to go 6 units right, and it definitely doesn't always have to go right, yeah? So all we have to do is find one of these points, but the real reason that we should be able to pick C is because C has an x-coordinate of negative 4, right? So think about it. This is on the line, x equals negative 4, right? This point is right here, C. So if I reflect it, C prime is going to be right on top, and that means it did not move 6 units right, right? So this statement is not true, and neither of these could be a counterexample. And the reason they can't be a counterexample was because if I put 7 right here and put a point there, this is 3 points, 3 steps away, right? So to reflect it, I'd have to go another 3 steps. But 3 plus 3 is 6, right? So both of these steps, A and B, both of these do take 6 steps, right? And we're not looking for an example, we're looking for a counter example. All right? So these would both be examples. But again, we don't want examples. We want counter examples. All right? So for this last one, you guys should try to think about what happened. It says that a point will be translated 4 units down. Okay? Now, we think about it, if this went across the bigger number first, right? And then it went across y equals 3. So that's when we go down instead of up. And these mirrors are 2 apart, right? 5 minus 3 is 2, and 2 times 2 is 4. Okay, guys, this one's true, based on our conversation earlier. I'm going to cut off the video here. Good luck studying. Send me an email if you need anything else, all right?